Okay, so right click, create shader, unlit shader, create, okay, shader, unlit shader. Is it okay? So we can type grayscale. Okay, so this is your sample code. Okay, so this is the sample code that you have. Okay, now, okay, for this sample code, okay, to write this one, you can see this is the COL that refers to the columns and the colors. So actually, you can write it here. Okay, so how to change to the um, grayscale? Okay, we go back to our formula. Okay, our formula is maximum RGB plus minimum RGB divided by 2. So this is the formulas that we wanted to implement. Okay, so for the R, so we can get the CLO is equals to maximum dot R. In not mistaken, the maximums only can use for two. Dot G. Okay, try can three or not? Can use three? Try first, If I'm not mistaken, only can use two. So plus minimum hold dot R GB and then divided by 2. So you can see you will get errors because the maxima is now matching 3 parameter. So because only have 2, so that you need to until here the maximum. Okay, and then open another one maximum. Correct. Okay, the minimum as well. Need to have this. Then minimum. Is it correct? This one with this one. Okay. So now we check our error. So because of the maximum can only put two parameters, two value here. So we need to test with the RG first and then get the maximum for this and then compare again, see which one. Then divided by 2. So this is the sample code and then we put semicolon here. Okay, so now right click, create material. So this is the grayscale material that we have now. So we can put our image. We put this one as an example. So you see now become grayscale. Okay, so this is the simple code that we have. Okay, for this part. Okay, for easy, I will directly update it to my web page. Okay, so you can have see this one if you modify to your things. Okay, for example, you put my code. Okay, so you say this one is the luminosity. Okay, so once you save this one, you can see for your this one. Okay, it will change to my code luminosity already. So if you want to search for it, now we will change to the directory is my code luminosity. Okay, so this one no issue, right? Okay, so now we continue with another. Can you do this? Okay, do this one, the average. Okay, so this one average, same thing, very simple. You goes to this one. Okay, this is your example. So this one we comment already, command. Okay, so we need to type this one. Okay, it's very simple. It will be called equals to, okay, for example, the call dot r plus call dot g plus call dot b gb divided by 3. So this is your average. This one is average. Okay. Okay, same thing for your grayscale. This one is grayscale 2. Yeah. Suppose we open new one to compare. Okay, now we open new one to compare. So this one is the luminosity. So we on another create shader and lead shader, and we call it as an average, average grayscale. Okay, average grayscale. So now we type the thing here. Okay, we type this one. Okay, so unlit average. Okay, we can put it this one. Okay, we call it as a average. Average. Okay, so now this is the sample code for the code dot r, code dot g plus code dot b divided by 3. So the same thing, now we have this already. Okay, we right click create material, and this one we call it as an average. So we put the same image to do comparison, the average. So this one we using the luminosity and the average. So you'll notice the outcome is quite similar. Okay. Or you can compare with a different pictures without photos images. Okay, I'm using this one. Okay, so you can place it. What is the format? Oh, okay. If your format is incorrect, okay, you can directly goes to open with your pen. Okay, so save it. Save as JPEG. So for us, JPG, save. So now you have this. Drag it. Okay, so you can try with the grayscale, and this one, try with this one. Okay, so you can see the comparison, got difference, very similar. The outcome we can say they're very similar, but this one you'll see it will be more darker in this three, correct or not? Can see the difference? Cannot. Very similar. Huh? Suppose got difference. Okay, this one darker. Okay, this one brighter. Suppose it will be have a different. Maybe this image cannot see much. Huh? No lah. Minimum, maximums. You using other image also look very similar. Suppose it will be slightly similar because grayscale mah, so normally will be quite similar lah. You see this part also difference this one more brighter, this one more brighter and this one more darker. So the intensity difference a bit only lah. Can you see the difference? You see this one more darker. Maybe you put it together, so we put aside. You can see this part now. Okay, so next one more. We put it in front a bit to do comparison. We'll have the lightness, right? We'll have this one called this one is called lightness. This one is luminosity. So terbalik already. Sorry. This one is lightness. Okay. So then we have the average, and the coding will be this one. Okay, now we have the luminosity, grayscale luminosity. Okay, type the luminosity sample. We have this, copy. Okay, so how do you write this one? Okay, you can have a new one. Okay, so right click, create shader, unlit shader. We call it as a luminosity. Okay, double click it. Okay, so now we wanted to write the coding for this. This is our formula. So how to write this? So CLO is equals to 0.21 times call.r plus 0.72 times call.g plus 0.07 times call.b. Okay, so this is our outcome. Right click, create material. We call it as a unlit luminosity here, and then our image, and we put it here. Okay. Oh, very similar. Three of them, the outcome quite similar. Not much difference. Just the intensity will be a little bit different. Okay, but the outcome will be the same. So next, so this one is a grayscale. You can make it like grayscale. Okay, you put everything inside. Okay. Okay, now we go to another. We call it as a threshold. The meaning of threshold addition is your grayscale. and threshold is black and white, means that only have two level, which is black and white. We all know that white is 1, black is 0. So how to do this? Okay, so the algorithm will be, okay, this threshold is used for segmentation. Sometimes we have the, okay, want to scan how many coins in the face there. Okay, for example, coin segmentation, for example. Okay, so you can see the image like this. Okay, so this one you have the coin putting on the camera. So you wanted to count how many coin it is. So it will be segmented like this. Uh, so now you can calculate how much coin that you have. So how many coin that you have lah. So you see the B and W. So you can see. Okay, so you are black and white like this. Okay. So now for our threshold used for segmentation. Okay. So select the area of interest of an image. We'll ignore the part that we are not concerned with lah. Okay, so this is the algorithm. You can see the threshold. Okay, when the image value is more than a certain level, it will return 1, this is white, and else it will return 0. Okay, so this is the threshold algorithm. Okay, we wanted to change to the grayscale first. Okay, which type of grayscale? And then your grayscale is more than a certain value. Okay, so if more than the certain value, it will be 1, okay, else it will be 0. Okay, so we need to do this. Okay, can you do by yourself? Okay, so this one to do, okay, is just using if else only, right? Okay, threshold, so right click, create, scripting, I'm sorry, shader, unlit shader, and we call it as a threshold. So for our threshold here, okay, this one, okay, will just like if, okay, COLs. Oh, we need to have a grayscale first. So you grab one of the grayscale. For example, we get this grayscale code. Okay, we get this value. Okay, so we grayscale first. So and then we just type if. Okay, you can get one of the channel if coded R. Okay, is more than 0.5. Okay, so the call will be equals to 1, else it will call equals to 0. Okay, so for our threshold, right click, create material, so our image, same thing, you can have the image with this for us. Okay, wow, so black so now you have this okay, so we wanted to make it adjustable, so we can have her properties. Okay, okay, look at this property. So this is the variable name. Okay, this is the variable name, and this is the GUI name, and this is the type, and this is the values, default value. So you can look at this example. Okay, so now we have a threshold here, and this threshold, it can be the value range from 0 to 1, right? Okay, so now we wanted to type this, so it can be like we have the threshold value with that threshold, and this is the text that we have, so we can type threshold, And then for this one we can type it like range, the example range 0 to 1. Okay, so it can be range, so our range is 0 to 1, and we can have the values that is the 0 0.5 here. No semicolon behind, no semicolons for our properties. Okay, so for these properties, we need to declare it. So you can see the declaration will be something here. Okay, you can type the float, paste it here. You can paste the threshold here. So now your threshold, this you put it here. Okay, replace with this 0 0.5. So now, okay, when you look at your this one, okay, you see it can be adjustable. So like this. Okay, now you have this. If we have a coin image, for example, we have a coin here. Okay, so we have a coins. Okay, we have this. Okay, save images, coins. Okay, so now we place it our coins. Place our coins here. Okay, so for our coins we put it here. So now you can see, you can find the coins, how many coins that you have. Okay, they are segmented already. Okay, okay, to do this brightness, so we need to have the brightness value range from the -1 to 1. So this is our color value 1. The O value plus the brightness will equals to our brightness. So now we can see the sample of the brightness. This is our PPT, okay, for our format picture. Okay, so now you can see the correction. Okay, the picture correction here, you can see this is your brightness. So you see when you're increasing your brightness, it will become white, so until the end 100% it will be white color. Okay, so for the brightness reducing subtraction, when it goes to the values 100% -1, it will be black colors. Okay, so now we wanted to do this for our shader code. So for our brightness, okay, right click, create. Okay, we call it as a shader and unlit shader, and we call it as a brightness. Okay, brightness, enter. So double click the brightness, and we'll have the brightness here. We type brightness. Okay, and the text will appear as a brightness. Okay, we are using the range. The range, because we have a negative value, so we type -1 and 1 here. Okay, so and then our value, you can have a 0 0.1, for example, for the brightness. No semicolons here. Copy your parameters here, copy, and you put it somewhere here. We call it as a float brightness and semicolon. So for the brightness, our values is equals to core plus equals to brightness value. Okay, oh, sorry, it's brightness. Okay, brightness value. Okay, so now, okay, this is our brightness. Right click, create, okay, material, and we call it as a brightness. Okay, this is our image. Okay, and we place it here. So when you adjust, it will be the brightness, something like this. If you 0 means that this is your original image, and you increasing the brightness, it will slowly become white colors, or the brightness. Okay, and this one is the subtraction of the brightness. Okay, 1 and -1, and this one, oh, so this is the brightness. Is it okay? So we continue. Okay, this is the brightness. Okay, so brightness subtraction and brightness addition. So why we need to use brightness? Image enhancements lah, preprocessing, artistic effects, and medical effect image. Because sometimes the image that we get it is too dark, so we need to adjust the brightness lah. Okay, so to improve the visualization to enable the features extraction lah.
Image enhancement. Improved visualization. Images captured in low light conditions or with uneven illumination can be difficult to analyze. Brightness adjustments can improve visibility by making details more apparent in darker areas or reducing glare in overly bright regions. Feature extraction. Many image processing algorithms rely on identifying specific features within an image. Brightness adjustments can enhance the contrast between features and their surroundings, making them easier to detect and extract. Pre-processing for other operations. Normalization. Brightness variations across images can negatively impact the performance of subsequent image processing tasks. Adjusting brightness can help normalize the intensity range across different images, leading to more consistent and reliable results. Thresholding. Thresholding is a technique for converting grayscale images to binary images. The success of thresholding often depends on good contrast between objects and the background. Brightness adjustments can be used to optimize the separation between these regions before applying thresholding.
Okay, so you can adjust it, the brightness, then after that you adjust already. So make it more contrast already, then you do the thresholding. Okay, so for the artistic effects.
Artistic effects. Mood and tone setting. Brightness adjustments can be used to create specific moods or tones in an image. Increasing brightness can create a cheerful or energetic feeling, while decreasing it can evoke a more somber or mysterious atmosphere. Simulated lighting effects. By adjusting brightness and contrast in specific areas, you can simulate different lighting conditions, such as adding highlights or shadows to enhance the perceived depth and realism of an image.
So for the medical imaging.
Medical imaging. Improved diagnosis. In medical imaging like X-rays, subtle variations in brightness can be crucial for detecting abnormalities. Brightness adjustments can help medical professionals better distinguish between healthy and diseased tissues.
Okay, so the brightness adjustment in game.
Post-processing effects. Environment lighting. Games can dynamically adjust brightness based on the time of day or the lighting conditions within a specific area. Example: brighter for sunny outdoor areas, darker for caves. This is often achieved through predefined lighting profiles or real-time adjustments based on the scene's light sources. Exposure. Similar to photography, games can simulate camera exposure by adjusting brightness based on the overall scene luminance. This can create a more realistic dynamic range, adjusting brightness as the player moves from bright to dark areas. Bloom and HDR. Techniques like bloom and high dynamic range, HDR, rendering can be used to simulate the way our eyes perceive light. These effects can adjust brightness to create a sense of glare or blooming in overly bright areas, while enhancing details in shadows.
Okay, for example, the exposures is sometimes we from a dark place, we go to the that suddenly we go to the bright area, so actually our eye it will be more brightness. So that will be simulate our eye precision. So exposure effects. So you can see if you have exposure. Okay, then suddenly took out very bright. So exposure. Okay, so no broom. Wait, small mediums. Okay, so for the contrast, so we